In the off chance anyone else wants to make their Turnigy Reaktor charger remotely controlled, I'm going to do a little tutorial on how I made mine remotely controllable. So, the goal of the project is basically just to allow me to push the buttons on the charger remotely without having to physically hit all the buttons all the times I need to. How I did this as a quick overview is, first you'll see cut a bit of a hole in the side of the charger and ran some wires out from underneath. They're just kind of hanging out in the bottom for now. And those are wired up to here to a breadboard with a couple opto-isolators and a few miscellaneous resistors. What this will allow me to do is, by connecting one of these two wires to the positive rail of the breadboard, I can hit the buttons on the charger. And this little blue LED here will blink when the absurdly loud beeper on the charger beeps. So I'll do a quick little demonstration of that. Alright, now everything's powered up. The reactor's plugged into a 12-volt server power supply, and the breadboard's getting power through the Arduino's USB port. That's just plugged into a USB charger. And the Arduino's not doing anything, so you can just kind of ignore that half of the board. So, with everything powered up, the first thing you'll notice is each time I press the button, the charger beeps annoyingly loudly. And every time I push the button, the little blue LED on the breadboard beeps or blinks in correspondence to each beep. So, that's one part of it, so I can listen for each beep from the charger. Now, I can also remotely control the buttons by using one of these wires and connecting it to the 5-volt rail of the breadboard. And each time I do that, it triggers the stop button being pressed, which cycles through all the options on the charger. The other one is the start button, which will go into the menu of each part of the charger. Those are all the controls I needed for my current project, but you could easily wire in the plus and minus buttons as well. So that's pretty simple in how it works. Now I'll give you a teardown of how the charger needs to be modified in order to support this. So, first thing, I'm going to unplug everything and then start taking apart the charger. So the first step is to remove the 4 screws on each side holding the 2 side panels on. The output side will just kind of fall off after the screws are removed. The input side has the wires going through it, so it'll just kind of hang out of the way there. That's pretty straightforward. Just make sure you have a good Phillips head screwdriver that fits, because the screws come from the factory pretty tight in there and they're kind of hard to get out without stripping and messing everything up. Now, to remove the face of the charger, it's really important to remove it like this. Now, I've already done this, but the charger will be kind of wedged underneath there, the front panel. It slips into place, and do not try and remove it any other way than this. If you try and slide it out, you'll be in for big trouble. I did that the first time I removed the charger, and it took hours. Don't do that. Someone on RC Groups pointed out that you can just pop it off like this, because there's a little lip there that's designed to just kind of pop in and out, and it made everything much easier. Now, the important part we're going to want to look at is the connector for the buttons. There are 5 pins there, and the pinout is on the far right is a common ground connector. Then you've got the 4 buttons in correspondence to the order on the front panel. So you got start, minus, plus, or stop, minus, plus, start. Then common ground. And how you will control the charger is pretty simple. If you ground out a connector, a pin, to the common ground, that button will be triggered. So to trigger the stop button, all you do is connect the stop to ground, and the charger will stop. And on the back side, we'll be doing our modifications. To get to the back side, we'll have to remove the circuit board from the bottom of the charger. There are 4 screws hidden around. 3 of them are pretty obvious. One's here, one's in the middle of the inductor, one's down by the connector, and there's one hiding underneath the input wires, so don't forget about that one. Now, with those 4 screws removed carefully, you can pop out the circuit board. The circuit board can be removed in a similar way to how the front cover was. You can just kind of pivot it upward and it can slide out with enough space. But it'll be a little bit stuck into place after the screws are removed due to these 6 thermal pads, which are actually the reason why I'm opening up my charger again after finishing the modification, because I'm going to replace these thermal pads, and I recommend you do the same, as they kind of get squished into place, and when you put everything back together, they won't necessarily have the same amount of contact force as before. And these are important as they allow all the heat from the hot components on the bottom of the board to go to the case, and I don't want those to be overheated just simply because the thermal pads are worn out. Now, at this point, you can slide the panel here down a little bit, and at this point I'd recommend cutting a slot in the side of it where you can run wires out from underneath the board. Now, I had already done this modification earlier before doing the remote control modification because, as you can see, there's only 5 slits here on this panel for air intake, and there are none on the other panel. So those 5 little slits are a lot smaller than the air output space on the fan. And my charger got kind of hot when charging here in the garage at 90 to 95 degrees Fahrenheit in the summer. Someone on some other forum recommended they did the same thing, and it helped quite a bit. So I decided to do it, and it worked out nicely. On the back side of the board is where we'll begin the modifications. So up along the top here, you'll see the pin headers for the connector on the front, which go to the buttons. And then over here, you've got the 2 pins for the beeper. And I want to be able to listen to the beeper and hit the buttons, so I attach wires to both of those. Now, similar to how the wiring is on the front of the board, you got the common ground all the way on the right side. Then you've got what I believe is the start button, and on the far left is the stop button. And over here, the positive of the beeper is closest to the buttons, and then the negative is closest to what would be the top of the charger. After you attach a wire to these, I decided to use servo connectors because I got tons of servo connectors just laying around. But after doing this, I realized I probably should have used a different method. The thing is, these servo connectors are too thick. The female housings, the plastic housing is too thick to fit underneath the board once everything's put back together. You can't tighten the screws down as everything is squashed from the thick connectors. So what I had to do, unfortunately, is strip off the outer female housing, leaving the exposed male pins underneath. And if I can unplug this, you'll see it's just a bunch of pins sticking out over the circuit board. And I used double-sided tape to stick these down to empty spots of the board, so they're pretty sturdy. I'm not too worried about these pins bending into the circuit board and shorting out. However, if I were to do this again, I would have used longer connectors, longer wires, so that the servo connectors could go outside the charger, underneath the bottom of the charger, and then plug in there. Because the other drawback of this method is that if I want to unplug this, I can do that without taking apart the charger. If I want to plug it back in, the whole thing's got to come out. For this point, I think it's a good time to cut out new thermal pads here. So these little ones here, they're just a silicone thermally conductive material. There's no thermal paste or anything like that. And it's pretty simple. I just bought a $4 sheet like this on eBay. It's 100 millimeters by 100 by 1 millimeter thick. And it's pretty interesting stuff. When you feel it, it feels cold, like you're touching metal, which of course means it's nice and thermally conductive, which means it'll absorb and transfer heat quite readily. It's also rather sticky, but it doesn't leave a residue, and it's not like a glue or anything. It's just a very sticky silicone pad. So I'll just cut out appropriate shapes like this from that, put them in place here. It leaves a little bit of residue here, so it'll be pretty easy to line them up, and when everything is reassembled, they will be squished into place just like these. Now the new silicone pads are cut out, and they're still in their plastic housings as they're really sticky. It's pretty interesting. It's almost like a clay. That's what it feels like, but obviously it's silicone of some sort. Anyway, I've lined them all up, made sure they're approximately the right size, and now I'll just attach them or remove the plastic and stick them into place. The material is super easy to cut and super easy to tear as well, so be a little bit careful, but scissors work just fine for cutting off anything here, cutting a small strip off if you cut it too wide, and everything will just kind of squish into place a little bit as well. You can see these are kind of squished around the edges, so it doesn't have to be exactly the right size. As long as you can fit the three over here close together. I did have to trim the middle one, as oversizing it means they didn't really align quite as well. I decided to take a bit of a detour and fix that annoyingly loud buzzer while I had the charger all apart. So the buzzer is wedged underneath the LCD screen here, which is really inconvenient because previously on the iCharger 106B that I had taken apart, there was a buzzer that stuck out the side in this little slot in the circuit board, which looks like it's designed for the buzzer to sit out. So the end of it was right here, and I just put a piece of tape over it. However, this one is wedged underneath here, and let's see if I can show you. It's that part right there. So what I did is removed 3 screws holding the LCD screen firmly in place. This one over here is unpopulated as the USB port's in the way. And so only this row of pin headers here is holding the board up. Then I used a little piece of skewer or whatever it is on the workbench to prop up the circuit board slightly. Now from here, let's see if I can get this illuminated. In there, don't know how visible that is, on the buzzer, with enough space between the top of the board now, I used a X-Acto knife with a piece of electrical tape on top of it to wedge a little piece of electrical tape over top of the opening on the buzzer. And then I used another X-Acto knife with my other hand to push down the tape firmly into place. Now when I put everything back together, the buzzer should be much quieter if it works as well as it did with my 106B. Now as a quick overview of the reassembly process, I've already screwed the 3 screws for the LCD screen back into place. I've got the thermal pads almost ready to go. All I need to do is, right before I put the board in, take the top level layer of plastic off of the silicone pads, as once again they're really sticky. They like to collect dust and dirt, and that's not very thermally conductive. On the bottom of the board, we've made all the modifications necessary, connected the common ground wire and 2 of the 4 5-volt wires for the 2 buttons. We've connected wires to the buzzer. The buzzer has been quieted by the tape on top of it when we pried up the LCD screen. Connectors are all in place, and there is a slot on the input side of the charger so that the wires can come out of the charger. Now, when we put the board into place, it's not particularly fragile. You'll just need to kind of wedge it in upward and then slide it down. So you want to come in underneath and then push it in. Alright, we're nearly finished reassembling everything. The board is screwed into place. Now, when you screw in the top 2 screws here, you'll want to make sure that they are screwed in pretty tight, as you'll be squishing the new uncompressed thermal pads you put into place. So you'll feel as you're screwing them in that they will go easy, and then there'll be a part to where they're not too hard to turn. That's where you're squishing everything in, and then finally they'll lock into place like the bottom 2 screws do. I also shined a light down the side of the charger so I could verify that the thermal pads were all in the right places and they were squishing into place. There's no gaps underneath all the components on the bottom of the board. They look pretty good to me. Then for the front panel, you'll just want to place it down in front of the charger, plug in the fan connector, and I found it very helpful to use some needle nose pliers to line up the pins for the front panel connector there. Afterwards, we're just going to slide the front panel into place. You'll have to be a little careful with that flexible cable. I kind of wedged the extra underneath the screen board there, Alright, everything's back together, the sides are screwed in, and we are ready for the first power up. I'm really hoping that, well, first of all, that it doesn't blow up, and secondly, that the buzzer is much quieter. So, here we go. Alright, that's encouraging. Buzzer, still kind of loud, but not as bad as before. The piercing part of it has been taken off, but still louder than I would have liked. Now for a quick overview of the circuit on the breadboard. There's really nothing to it. I've got 3 opto isolators, and those are basically just, they will prevent any high voltage inputs on this side from getting into the charger. So if I mess up, or if the ground voltage on this side is not the same as the ground voltage in the charger, then the opto isolators will prevent any issues from that. This probably isn't necessary, especially not if you're not doing some kind of crazy system like I am, but I decided to play it safe and put these in. So I just have resistors here because opto isolators are basically, the input side is an LED and the output side is a transistor. So you need resistors to limit the current into the LED, and then also I put resistors on the output transistor because when I had the charger apart initially, I measured that when you push one of these buttons, it goes from a high impedance to about 80 to 120 ohms. So as you hold the button down, that's about 80 ohms of resistance. So I matched the resistors on the outputs going into the charger to be 80 ohm resistors. Seems to work fine, and it's probably quite safe. Overall, from there, I can basically modify my Arduino code to be able to connect to these wires and then remotely control the buttons. So that is my modification. Hopefully it continues to work well. I have a bunch of projects for this, and that is all.